Example 10.10, page 309. Okay, here we have a uniform rod of length L and mass M is attached at one end to a frictionless pivot. So here we have a pivot at the point O and is free to rotate about the pivot in the vertical plane. The rod is released. I mean, initially here V equals to O. The rod is released down uh, from rest in the horizontal position. What is the initial I mean at this position? Okay, this is the initial position. Maybe the final position will be here or here at any position. Okay, but I talk just about the initial position at this point. I have to find the initial angular acceleration. So we have to find alpha initial of the rod and the initial linear acceleration A of which point? A of the point of its right end. I mean, for example, if we have a point A here, I have to calculate A of A. Before starting the solution, let me explain one point. Here, for at initial time, if we have a point A or a point B or any point on the road, at initial time, all the points have the same omega and the same alpha. Okay, so time initial, we have omega initial and we have alpha initial. Here, omega of A equals to omega of any other point equals to omega I. And the same for alpha. Alpha A equals to alpha B equals to alpha initial. This is about omega and alpha. But about V and A, we don't have the same case. You have to precise the point. So here we have VA is not equal to VB. So here we have VA and we have VB and so on. And the same for A. We have A of A, we have A of B, and so on. We have to calculate A. In this problem, I ask you to calculate alpha initial. Okay, I don't precise the point because all have the same alpha. But about A, I ask you to calculate A of A. So I have to precise the point, A of A. Okay, let me start the solution. To calculate alpha or A, we have a simple relation, summation of tau equals to I times alpha. Okay, also we have summation of F equals to M times A. Okay, here in the case of rotational motion, I use this relation. Here, on the road, we have the reaction R and we have the weight mg. The pivot point here is at O. Okay, so you have to say pivot point at O. So you can say directly tau of R equals to 0. Why? Because R is passing through the pivot. Okay, so the total tau is equal to tau of mg. we have only mg equals to I times alpha. You know, mg has only one component. How you know? You have to join the by a line the pivot to mg like this. And here you see we have only one component of mg. It's okay. Second point, what we have to do, I tell you an important point. You know, if we have a clockwise, if we have a clockwise rotation like this situation, look here, mg uh, push or rotates the object down, okay, down. So in the direction of the clockwise. So we said if we have a clockwise rotation, tau must be negative. If we have a anti-clockwise rotation, we have a positive tau. In this case, mg is pushing the object in the clockwise direction. So you can say directly minus tau mg equals to I times alpha. Okay? You know, minus, here you put tau of mg in the absolute value. Here I don't calculate tau, I calculate alpha or a. So you have to put the value of tau. You know tau equals that to the distance r times mg. Only like this. Equals to I times alpha. What is the distance between mg and the pivot point? Here we have mg and pivot point. The distance equals to L over 2. So we get here minus L over 2, L over 2 times mg equals to I times alpha. So finally we can write alpha equals to minus L over 2 mg divided by I. Here, what about I? I, you know here, I equals to ICM plus MD square. Okay? In general, I give you ICM and you can calculate D. D is a distance between mg and the pivot point. Okay? So I can give you ICM. Here, I can give you ICM and you can calculate I, or I can give you I directly. Okay, here I give you the total value of I, which is equal to 1 over 3 ml square. Okay, this is the summation of ICM plus MD square. We substitute the value of I here, we get minus L over 2 mg divided by I, 1 over 3 ml square. We can eliminate, cancel L and L, M and M. We get finally 3 minus 3G divided by 2L. Okay, so alpha equals to minus 3G divided by 2L. This is a vector quantity. Okay, what I mean by minus, it means that the object is moving clockwise. Okay, when we have a clockwise rotation, alpha must be negative. If we have anti-clockwise rotation, alpha must be positive. Here, alpha, the angular acceleration, is in the negative direction. Okay, this is the negative direction. Alpha is like this. Alpha vector. Okay, so now I want to calculate the linear acceleration. You know, we have a relation between A and alpha. A equals to R times alpha. I want A for the point A at this side equals to RA times alpha initial. You know, RA is the radius. If we have the rotational motion, A will turn like this. Okay, the radius here will be L. So A of A equals to L times alpha initial, which is equal to minus 3G divided by 2L. L and L, we get finally A of the point A equals to minus 3G times over 2. You know, when V increases, so V and A, here you can say a tangent, okay? I take a tangent, it's important. A tangent equals to R times alpha, not only a tangent, only a tangent. You know, if V increases, V and a tangent have same direction. Okay, in this case, we have initial velocity equals to 0, and we released the system, so V increases. In this case, V, you know, V is tangent to the trajectory, is like this. This one is V of A. As V increases, so we get A tangent must have the same direction. A tangent and VA are in the negative direction, down, in the negative direction. As you see here, we have negative, and here we have negative. That's all about this example. Here I can ask you to find only the value of tau mg. You know, tau mg equals to R cross mg. I have to find the direction of tau. We put the magnitude R times mg, and here we put the direction. R is the distance between the pivot point and mg equals to L over 2 times mg. What is the direction? You know, you have to use your right hand rule. Between R is a vector between the pivot point and mg. You have R in the direction of your fingers. mg must be out of your palm, must be down. This is your hand rule, and you have your finger will be into the page. When I say into the page, I mean X, and X is minus J. So here we have minus J. Okay, minus J. the magnitude, and the direction.